welcome to my beer talk presentation regarding MQTT security. Let's jump into the agenda. So we'll have a short introduction regarding why I chose this topic. We'll then see some MQTT fundamentals. We'll go into some security related topics for MQTT. I'll then show you how I analyze this protocol and what kind of findings that I found there. We'll then see a short demo regarding an issue which can arise with ACL files, as well as a vulnerability that I found. We'll then go into the recommendations, and if you have any questions, you can ask them at the end. So maybe to me, who am I? So my name is Misha Bachmann. I work at Compass since 2018. At Compass, I'm primarily a pen tester. I like to do Windows and AD internal penetration tests, but also web applications. Apart from my pen testing, I'm also a teacher. I teach the internal network and system security course, as well as web application security. Since last year, I joined the DFIR team, and there I pretty much help out wherever it needs it. So why MQTT? I did some studies beside work, and I did these at the Lucerne University of Applied Science and Arts. And there I had to write a master thesis. And the topic that I chose for this was MQTT. Reason for this being that the Internet of Things or operational technology is a field which is growing year for year. And one of the most used protocols that we see there is the message queuing telemetry transport, which is used to send data back and forth between different devices. If we have a look at the Shodan search for MQTT, we can see that there are around 500,000 of devices which are exposing an MQTT port to the internet. And most of these brokers that were found support version 3.11, and we're running the Eclipse Mosquito broker. So for my work, I focused on the version 3.11 and this broker and clients as well. So to the fundamentals, Oasis Open is a non-profit consortium which includes companies like IBM, Microsoft, and Red Hat. And Oasis released the MQTT version 3.11 and version 5. 3.11 was also adopted by the ISO standard 20922 back in 2016. And for version 5, there's not been a standard yet released from ISO, which was also one of the reasons I concentrated on this version. MQTT uses TCP to transport packets over the network, and it mostly does this over port 1883 or 8883. The difference being that the last one is using TLS for encryption. The standard also allows to send these MQTT packets over WebSockets, which makes the integration a bit more easier, as port 80 or 443 are mostly open on the firewalls. So let's have a look at how this can work. We have here our broker, which is the central part of the solution. And we have on the left 2 devices and on the right 2 sensors. So the device in the top left corner sends a subscribe packet and says, I want to subscribe to this to any values which is sent regarding the temperature. And on the right side, we now have our temperature sensor, which publishes such a packet, and in there it sends the value 25.6. And this value will then be sent from the broker to any device which has published this topic. In this case, we have 2 devices, so both of them will receive this value. But on the other side, we also have a door sensor which publishes a value called locked, and this is only subscribed by one of these 2 devices here, so only this one will receive the value. The entire communication in MQTT are done via control packets, and these are built up in 3 parts. We have the fixed header, which is always going to be the 2 bytes. We have a variable header, which, as the name already says, is variable depending on this regarding the size, as well as a payload, which is also variable. Here we have an overview of all control package which exist in MQTT version 3.11, total of 14. And also from the color coding, we can see if the variable header or the payload are required for this publish packet or for this control packet. Let's just have a look at the first example. We have the connect packet, which allows a client to connect to a server. So after the TCP handshake is being performed, the client sends this connect packet to the server saying, hey, I would like to connect via MQTT. We then have the variable header, which includes information like the protocol version it wants to use. And in the payload, for instance, there is a possibility to include username and password for authentication. So from all these 14 control packets, the most used are the connect, the publish to publish a packet or a message, the subscribe to subscribe to a topic which will receive such a message, and the disconnect packet, which is sent at the end of the communication. So how do these topics look like? They're similarly built up like a file hierarchy in Linux. Here we have 3 examples: HQ main entrance door state, the door lock, as well as the HQ server room door lock. And when you publish a message, you always have to send this to a topic. And when you subscribe to a message, it's also always done via the topic itself. Additionally, we have the possibility to use wildcards within MQTT. There are 2 symbols we can use. One of them is being the hashtag and the other one being the plus symbol. So the hashtag will pretty much replace everything from that level onwards, meaning if we compare it with our example at the top, it will subscribe to door state and door lock. Or if we look at the bottom example, this pretty much just replaces any value which is present on the broker within that hierarchy level. So in this case, it will be main entrance and server room, which is being replaced by the plus. If we have a look at a quick example here, we see on the left we have our temperature dashboard, in the middle we have a broker, and on the right we have a temperature sensor. So the dashboard sends a connect to the broker and establish a connection. He will then receive a connect ACK. We then have a sensor which publishes the value 25 to the topic temperature roof. And in this case, it also has a flag in the publish package which says retain this message. And pretty much what this does is, as soon as a client subscribes to the specific topic, the broker will have this message kept back because of the retain flag, and will then publish it to any client which connects after the message has been sent. Then we have another publish which is sent. This time the value changes to 85. And this 85 is sent to any client which is currently subscribed to this topics, in this case, the dashboard. After the communication has completed, a disconnect control packet will be sent and the communication will then be closed. So the version 5.0 was released in March 2019, and this version does include a couple of interesting additions that we can look at right now. So I didn't list all of them, but just probably the most interesting ones. So the first one is a new control package that was introduced in version 5 called auth. And this allows for advanced authentication. So now it's possible to also do challenge and response procedures within the authentication process. Then there's a shared subscription packet. This pretty much allows multiple clients to subscribe to the same topic. And then when a message is released, the broker will understand which of these clients use the shared subscription and will only send the message to one of these. And this then can be used for load balancing, where these multiple clients send this message onwards to the same database. Additionally, there was a flow control introduced. This limits the amount of quality of service packets that can be queued. So in comparison to the normal publish packets, the quality of service packets actually expect that the broker will confirm the that he received the packet, and depending on the level, this will then be 2 or 4 messages sent forth and back between the client and the broker. Then another interesting feature which was introduced is the request and response. And this allows the client and broker to use request and response as we know it from HTTP. So in this case, in the published packet, there's a response topic defined, and the broker will then know where to send the response back to. So what are security relevant topics here? So MQTT is a very lightweight protocol, and it does not include a lot of features. This is actually already stated by the standard itself. And because of this, there are, let's say, a different stuff that we have to look at. One of these is that if we want to have functionality which detects repeated connection attempts, like denial of service attacks, or repeated authentication attempts, like brute force attacks, there is no functionality built within the protocol itself, meaning we will have to have a look if the broker can support these features. If not, then there has to be some kind of functionality built or put in front of the broker to provide this security. So in my case, looking at Eclipse Mosquito, neither of these two actually were implemented by the broker. Then the connect packet only allows to provide username and password for authentication. Here again, the standard does say you can kind of misuse these fields for transferring tokens, like via LDAP or OAuth authentication. But then again, it's not a proper solution, I guess. It's just more of a workaround which you can use to extend this authentication procedure. In the version 3.11, it's not possible to authenticate the server itself, meaning if you don't have mutual TLS enabled, you won't be able to do this on the protocol level. So the confidentiality integrity all relies within the TLS itself. I guess this is not that bad. The only issue that might arise here is that many IoT devices do not have a lot of hardware resources, and this can result in the device itself not being capable of running TLS. So this is something to keep in mind. Another topic which I guess we will see a lot in MQTT distributions is that the authorization checks on the topics themselves could probably be set to run quite easily, as I guess you'll have a lot of topics and a lot of messages. And if there's one mistake there, this could lead to leakage of information or even read permissions. So how did I analyze this protocol? I created a testing environment. So pretty much I enabled, or I created a hotspot on my device, had Wireshark running there, and had the Mosquito broker enabled. And then I had all my devices connected via Wi-Fi, and yeah, tried to understand how does this device work, how does this protocol look like, and get a better understanding of everything. So I'll quickly show you the devices that I looked at. The first one was a Shelly HNT for humid and temperature. This pretty much just measures the values, and you have the possibility to define a threshold. So for instance, if the temperature increases or decreases by 1 Celsius, then this device would enable the Wi-Fi module, connect to the broker, publish the new value, and then disable the wireless module again. So let's have a look at how we can analyze this device. So here I'm using the Mosquito sub, which allows me to subscribe to topics. This is also a tool which is integrated within Mosquito tools selection, I guess. So here we have a connection which connects to the broker defined with the -H. We have the -V, which tells us we don't only want to see the messages, but also the topic names. We'll have to define a client ID, which in this case is Linux client. And then at the end, we define the topic we would like to subscribe to. In this case, I'm using a wildcard so I can get all the topics back which are within the Shellys. So we see here one of the topics is the name of the device itself, Shelly HT, and kind of a combination of the MAC address. And here it has a topic called online, which has the value set to true. Additionally, there's also an announce, which is sent into the two different locations, which just pretty much announces that this device has connected and just gives a couple of further information of the device. Additionally, we also have an info, and in this info, we have a bit more of information provided about this device itself, like how much RAM is free or how long this device has been up. So as we can see, Shelly has decided to use JSON for most of the data they send or messages they send, but this is not defined by the standard, so you can pretty much define how you want to pack your information and send it over the network. At the end, we also have the values which are most interesting for the use of this product, so the temperature and the humidity. And we also have values like if it's or how much battery this device has, and also why this has been reported to this value. So in this case, there's a button on the device which you can press to manually have the device send the value back to the broker. If I would want to change the value of the temperature, I could use the Mosquitto pub for publish. This case very similar, define the topic, but now also additionally, I have the -m, which defines the message I want to send, in this case 28, which will be sent to the temperature topic. So the second device I looked at was the Shelly Duo. And this is a bit more interesting as you can not only read values which are sent from this device, but you can also write and control this device via MQTT. So here, very similar, we have a topic called light 0, and here we have the value on. We have a status which defines a couple of values like brightness or etc. And we also have an interesting topic here called command. And via this command, we are now able to interact with this device. So if we publish this off value to the command topic on the broker, pretty much the device is subscribed to this topic, meaning he will receive this off, and then he will turn the lights off. But we also have the possibility to use the set topic, which allows us to define multiple values. For instance, here, increasing the brightness to 60. So during my work, I did a total of 10 security tests against this testing environment. As already mentioned, the denial of service or brute force attacks were not detected by the Mosquitto broker. And one of these tests also led to a denial of service memory leak within the Mosquitto broker. So here I'll show you one of the tests that I did. This is called the slow denial of service against Internet of Things environments, or short SLOWIT. And this attack pretty much just connects the broker, sends a connect packet, and then keeps the connection open and repeats this procedure until the broker doesn't have any free connections anymore. So here I used a tool from the GitHub repo from Gianluca, which implemented this attack into a Python script. And yeah, pretty easy to define the broker, the ports, and you can start attacking. If we have a look on the broker side of the attack, we can see the broker identifies the client that was connecting. In this case, the client ID is always being iterated one higher, but it does not detect it and pretty much allows this attack to happen. Here, just a short view from Wireshark. We have our TCP handshake and then the connect command. We get the connect ACK, and then the attack is repeated. Okay, so for my work, I also created some security labs. This is the setup, how it looks like. So on the left, we have our computer, and then we have the solution built within Docker. And we have the possibility to connect via SSH to the attacker host. And this attacker host is inside a network where there's an MQTT broker exposing the MQTT port. And we have a backend which has 2 MQTT clients which send different information to the MQTT broker. We also additionally have a dashboard which connects to the broker and displays the information in a nice dashboard itself, which then can be accessed via HTTP. But for the demos I'm going to show you, this is not so relevant. Good. So here I'm going to connect now to the attacker host. So maybe the first thing we do when we're on a client, we want to see, okay, what do we have here where we connect it? So we can see we have this small network here. So let's start and search for MQTT ports. And I'll go for the entire network here. And then after the scan has completed, we can see, okay, there's a client.3, which has an MQTT port open. So in this case, I'm going to use Mosquito sub to subscribe. I'm going to define this host. Find the port. Now say I want to see the topics as well as the messages. Define my client ID, and now define the topic I want to subscribe to. So as I don't know anything about this broker, I'll just say, hey, I want to subscribe to every topic that I'm allowed to. And then I'll connect to this client or to the broker. So if we have a look at the messages here, we can see we have here HQ main entrance store state as a topic. And in this case, it's set to close or the value is closed. We have a lock, which is locked. We have some sensor information regarding battery, external power, etc. And we can see that this door is online. Now, additionally, we also see we have a server room here, which pretty much looks the same as the main entrance. But also what is happening is we can see here now there was a command sent unlock. Then the door lock has been unlocked. The state of the door changed to open. Then it was changed to closed again. A command was sent lock, and then the lock was in the end locked again. So I'm assuming now this might be maybe the main entrance where people are badging in to get to work. So let's see if we can misuse this somehow. So here I'll connect to the attacker host again. And now this time I'll use Mosquito pub for publish and define the host again. Port, I'll have to define client ID. This time I'll use a different one so I don't get kicked out of the other one. I'll have to define a topic. So let's go for server room, this time command. And I'm going to define a message here, and the message should be unlocked. So if I send this here, I can see the message has been sent to the server room door, unlock, and efficiently the door itself has really been unlocked. And now we're able to get into the server room. So maybe looking at the broker, and let's look at the configuration. And this is called ACL file. Okay, so this is the ACL configuration of the server. We can see here, if you're the user admin connecting, you'll be able to read the system tree, I guess, of all the messages, as well as write to all topics within the HQ. And here we have some ACLs defined for users which are not authenticated, so they are able to read within the HQ. And here we have now the problem, a wrong defined ACL. In this case, it's a read write onto the door of the command topic of the server room. Okay, so now I want to show you a vulnerability that I found within Eclipse Mosquito. So here I'm running the latest version of Mosquito, which is the version 2015. And here on the right side, I have a HTOP, which we can see how much memory is being used. And the attack here, which I'm going to show you, is very simple. So we have here pretty much just a socket which is being established. We have a connect, which is sent to the broker saying, hey, I want to use version 3.11. And then we have a while loop. And within this while loop, we always send a publish packet. And this has the quality of service set to level 2, meaning the broker should confirm this packet. Then the client will confirm that he received this confirmation, and then it will be released within memory. And of course, because we're only sending this packet without ever confirming any packets, the broker has a problem here. And in the end, yeah, this was resolved to the issue. So if we run this attack, we can now see here on the right side that after a while, the memory will increase. And if I stop this attack, you would expect the broker to release these packets again after a while. Yeah, could be like after a short time, could be after half an hour, but the problem here is that he never releases it. So how do we try to identify what the issue is here? So as we're assuming that this is being done via my published packets we're being sent, we think this is probably being not read within the heap itself. So here we have a pretty cool tool called heap track, which we can then direct to our Mosquito server again. Okay, this is running. Now I'll start my attack again. Wait for the memory to increase. Okay, we can see it's increasing. Good. Let's stop this again. Now we'll stop the heap track. And heap track now pretty much was able to record this allocation within memory. And we can now use heap track.gui. And he wrote us this nice file here. Good. So let's open this up. Okay. I hope you can see this. It's a bit small. But here we have now a top down. Yeah, I can't increase this, but I hope it's big enough for you to read. So here we have now a top down, and this pretty much goes and searches through all the different functionalities which allocated memory, and then displays this within the graphical view here. So I can open this up, main. I can see, okay, within main, we have a Mosquito main loop. Here we have a mux epol handle, etc., etc. Now we'll see, okay, this function is called packet read. Probably has something to do with our publish packet. Here we have a handle packet function, and we can carry on and view, okay, send underline command until we come to a functionality called Mosquito calloc, which sounds like a custom allocation functionality written by the developer of Mosquito. So with this view, we know where the memory is allocated within memory. But of course, the issue is where it's not being freed. So how do we find out where this issue is happening? I guess this took a lot of reading of code and trying to understand how the broker works of Mosquito. So it is open source, does make it a much more easier, of course. And initially, or let's say at the end, I found out that it's related to this netWrite function, which sends or returns a send of the libc function and sends this packet over the network. And the problem lies that this send receives an error. And we'll go to the packet mask here to see the netWrite functionality. So the netWrite functionality gets executed, the send from libc gets executed, and all the bytes which have been sent over the network are then written into this variable. And then we have the check here, which pretty much checks, has any information been sent over the network? If yes, then carry on with the normal code flow. If not, check for some errors. And in this case, the developer actually checks for 2 errors here. one being the E again, and the other one, the combat E, would block. And funny enough, it's exactly this error which is being generated by the send functionality, the E again, which pretty much means please try sending the packet again, as currently it's not possible. So pretty much the network interface is probably busy, and this is why this error is generated. So the error is actually cached within the code. And then here we have a mutex which is unlocked. And then we have a return of the value 0, meaning, hey, everything is fine. And here we have kind of a problem. So here we have now the packet which was allocated but not being freed, and it's returning out of this function with a success 0. So of course, I didn't read through all the source code to understand all the functionality it has, but like a quick, easy fix would have been to replace this return with a break, meaning that even if this error exists, it will break out of the if loop. And then further down, it would follow the code until we see here, we have a packet cleanup and then the mosquito free of the packet itself before returning the 0. Yes, that's it. So we'll carry on to the recommendations. I would recommend to use MQTT in the version 5 just because you have additional functionality you can use here, like flow control or authentication of the server. Yeah, of course, if the devices support the load of mutual TLS, do use mutual TLS, as this does increase security a lot in the solution. After implementing or building an MQTT solution, it's important to do some authorization checks, as these can be missed quite a lot. I guess we can compare this to file shares that we see within internal penetration tests, as mostly they are not, the ACLs are not set as well as they maybe should be. Don't only rely on username and password authentication, as if that's the only thing you have, it can be brute forced. Keep the broker up to date to ensure that the vulnerabilities are patched, new discovered vulnerabilities, and be sure to have a broker in place, or at least some solution which detects common attacks like repeated connections for authentication, or authentication or connections. Last but not least, of course, make sure that only authenticated access is exposed to the internet, and if possible, don't expose to the internet at all. Good. That will be the end of my presentation. Does anyone have any questions?